Namaste. Today in this video we are discussing about case-based reasoning. Okay, before case-based reasoning we will be solving this problem. Okay, so in previous video we have discussed about Bayesian network. Okay, statistical reasoning. So let us consider an example. Okay, in a clinic 10% of patients entering have liver disease, 5% of patients are alcoholic, 7% of patients diagnosed with liver disease are alcoholic, and we have to find the probability of patients who are alcoholic that have chance of liver disease. Okay, so 10% of patients entering have liver disease. Let us consider as PL. Okay, so it is 10%. So 10% means 10 by 100 is 0.1. Similarly, 5% of all are alcoholic. So let us consider as it is as PA. That means 5%. So 5% means 5 by 100 is 0.02. Sorry, 5. Okay, 0.05, not 0.02, 0.05. And next one is 7% of patients diagnosed with liver disease are alcoholic. That means both. Yes. So PL intersection A, it is 7%. So 7% means 0.07. So we have to calculate probability of patients who are alcoholic that have chance of liver disease. That means probability of alcoholic, okay, in and chance of liver disease. Probability of A when L given, that means. Okay, so it is calculated as by Bayesian theorem or Bayes theorem. We have calculated it as PL slash A into PA divided by PL. Yes, so put these values. PL A is, what is the PLA? Probability of L when A given. Okay, that means that is intersection of these two. So 0.07 into PA is 0.05 divided PL is 0.1. So please calculate its value. Okay, so we'll be moving to next topic, that is case-based reasoning. Okay, by the topic it says that case-based reasoning. So case-based reasoning is the process of solving new problem based on solution of similar past problem. Yes, so it can be analyzed with solving the case by lawyer. The lawyer reads the old cases and solves the new cases. Yes, so that is case-based reasoning. So let us consider an example. An automatic fix an engine by recalling another car and other car that exhibits similar symptoms, each using case-based reasoning. Okay, makes the car by recalling the previous information that is used for reconstructing the old car. Yes, so next example can be considered as, I have previously said that a lawyer who advocates a particular outcome in trial based on legal precedents, a judge creates case using case-based reasoning. That means solves new cases by recalling the information of previous solved case. Next example can be considered as an engineer copying working element of nature in treating nature as database of solution to problem. That means an engineer copies the working elements of previous problems to solve new problems. Okay, so case-based reasoning is a prominent kind of analogy making. It is not only powerful method for computer reasoning but also provides behavior in every human problem solving, or all reasoning is based on past cases personally experienced. case-based reasoning has been formalized for a purpose of computer reasoning as a four-step process. Okay, there are four-step process in case-based reasoning. So they are reuse, revise, retain, and retrieve. Okay, so retrieve. So first we'll be discuss about retrieve. Given a target problem, retrieve from memory cases relevant to solve it. Okay, a case consists of a problem, its solution, and annotation about how solution was derived. For example, Sabin wants to prepare a cappuccino. Okay, so let us consider an example of cappuccino. Okay, he wants to prepare. Being a novice, the most relevant experience he can recall is one in which he successfully made a coffee. Okay, so that is all about retrieve, and move to the reuse. Map the solution from the previous case to the target problem, which may involve adapting the solution as needed to fit new solution. Okay, so in retrieve process we have considered about the cappuccino example. Yes, so we use the same example in reuse. So in previous example, Sabin has to adapt its retrieve solution to include how much the coffee is to be used. Okay, that means he have used the coffee in, he have prepared the coffee in the past cases, and he is going to prepare cappuccino. Yes, so he have to reuse the retrieve solution so that he can include how much coffee to be used or stirred in a cup. So now we move to the revise. Having mapped the previous solution to the target situation, test new solution in the real world, and if necessary, revise. Suppose Sabin adapts its coffee solution by stirring the amount of coffee with milk. After mixing, he discovered that the cappuccino is not made, and then he revised and stirred the moment carefully. Okay, so by adding the coffee in the milk, stir it. If the cappuccino is not made, then we have to revise it in next process. Okay, revise it until we get the cappuccino. So next one is retain. After the solution has been successfully adapted to the target problem, solve the resulting experiment as a new case in memory. Sabin accordingly records the new found procedure for making cappuccino there by enriching his sets of stored experience and better preparing him for future cappuccino. Okay, so this is case-based reasoning, and I have considered example of making cappuccino. That means first retrieve the information of past experience, then reuse it and revise it until the cappuccino is not made, and if it is made, then we store this information for future purpose. So this is case-based reasoning, and it includes 4 steps. Okay, retrieve, reuse, revise, and retain. Okay, this is the cycle. So in this way we have finished the reasoning chapter, and in next video we will be discussing about export system. Thank you and bye bye.